Hello, in this tutorial we're going to look at synthesis. In fact, we're going to look at a method of synthesis known as subtractive synthesis. I'm going to be using the ESP, which is a plugin on Logic, and I've set this to what we describe as a vanilla patch, an initialized setting, and I am going to show you the different sections and what's going on with this. So first of all, we've got this section over here, and it's known as the oscillator, and we've got various waveforms in here. Each one of these waveforms has got a different amount of harmonic content in there. So if we start off with a sawtooth wave here, and we look at it in the graphic EQ here, I've got analyze on, and this little graphic EQ. So if I just press play on these notes down here, you will see it has a low frequency here, which is called the fundamental, and then it has harmonics over the top. So this is harmonic content. What we can do, if I filter out those lower frequencies, you can really get an idea of the sort of frequency range that is contained in a saw wave. And I can do that with this as well. Take these frequencies. Can you hear that? So that's taking out the high frequencies. So waveforms and all sounds have a collection of frequencies known as overtones. In this case, these are harmonics, meaning that they're in harmony with the fundamental, so the lowest frequency in this case. So the lowest frequencies give us an idea of pitch, and the overtones give us the timbre. In a sawtooth wave, we have what is known as odd and even harmonics. So if I press play again, you will see that frequency there, and then you will see that's the first partial, and then second frequency is the second harmonic, third harmonic, fourth harmonic, fifth, etc., etc. So odd and even harmonics are in there. If we look at a sawtooth wave, this only contains the first frequency, and then the third harmonic, the fifth harmonic, seventh, ninth, and all the odd harmonics. So it gives it a different sound. So let's mix those in. You can see those harmonics coming back in, take them out again. Okay, so that's very basically what's going on with an oscillator. So what we can do here is mix these waveforms together. Then we come on to this section here, which is known as a filter. And in this, we can filter out high frequencies, just like I did there. Look. So you've all played around with EQ, so that's just taking all the top end out, all the high frequencies out. Well, I can do that with this. So that is taking basically like an EQ, which cuts the high frequencies. What I can also do, at the point that it cuts off, so it's essentially doing that. It starts at a certain frequency, the cut-off point, cut-off frequency, and then it rolls off over time, taking out. It's not like a brick wall. Like, it's not so much like, oh, I can't really get brick wall with this, but it's not a straight line like that. It rolls off like this. At that point of cut-off, at the cut-off frequency, we can boost. So let's get a parametric EQ like this, and which one is this? And make the bell shape a lot narrower, like this. Oh, it's not doing it. Come on, where's the bell shape there? There we go. So if we play that, can you hear that? It's making that frequency there louder. So that's EQ, but if I got rid of that EQ, I can do that with this. So that's kind of like a little peak that we can put in there, and it gives that nice kind of wet sound, which is, which gives that synth really their sound. You always recognise a synth sound because it's got that sort of thing going on. Now we can shape that. We can make this filter, we can automate it. Not that we'll see it. We can use this thing called the ADSR, or the envelope section, to do that. So if I do this, it's like saying how much do I want to affect the filter? So I'm going to whack that on full. ADSR intensity, int intensity. So if I do this, I'm going to turn it up a little bit because it's a little bit low. What I can do with this is get the filter to, so that when I put the, because I've applied, this is saying, right, this is going to affect this by this amount. Let's turn that off again. What that's basically doing is doing this, pushing that filter up. It's making, this A stands for attack. So it's taking a long time for the filter to open. Let's do that a little bit. Yeah. Let's do it a little bit slower again. Can you see that, what's happening there? So it's starting off with this and then letting frequencies out. So it's automating that process by using this attack. Let's try it the other way around. So let's try decay.